Hello everyone. Yeah, welcome back to my class. Uh, this is a continuation of 2021 past question solution series in physics. In our last class, we stopped at question 30. So we're going to continue from there, which is question 31. So question 31 says, it says, the temperature at which the saturated vapor pressure in an enclosed liquid is equal to the atmospheric pressure is known as A, freezing point, B, standard temperature, C, boiling point, D, room temperature. So the correct answer is boiling point. Question 32. Determine the energy stored in an elastic material whose force constant is 1.2 exponential 5 and extend by 2 centimeters. So quickly, in exam setting, since you are looking for energy stored, remember that this is the formula. Energy stored is equal to half Ke squared when your force constant is given to you. And remember, this force constant, they can call it elastic constant, they can call it force constant, they can call it stiffness constant. You understand? So don't be confused. So this is the energy stored, half Ke squared. Exactly. So now our K is given to be 1.2 times 10 raised to power 5 Newton per meter, and the extension E is 2 centimeters. So convert this 2 centimeters to meter. To do that, you divide it by 100. That will give us a 0.02 meter. So we can now bring it here in our formula. E equal to half Ke squared. So that will be equal to, this same thing is like Ke squared over 2. Please don't be confused. So then we now plug in the value. You plug in the values. So what is the value? We have our E is equal to K is 1.2 times 10 raised to power 5, all multiplied by 0.02 all squared, then divided by 2. So that I have my E equal to, when you say that 1.2 exponential 5, then you multiply it by, okay, let's first of all you are doing it gently, 1.2 exponential 5, then multiply it by 0.02, you square 0.02, give us 4 exponential minus 4, all divided by 2. So we have E equal to 1.2 exponential 5, right, multiplied by 4 exponential minus 4. That will give us 48. So we have here to be 48 all over 2. Therefore, E will be equal to 24 joules. As simple as this. Exactly. So our correct option here is option A. So moving down to the next question, which is question 33. So 33 says, the mass of a copper deposited on the copper voltmeter is 450 grams when a current passed through it for 25 minutes, right? So calculate the current passing through the voltmeter. This is under the first law of Faraday's first law, that the mass of copper deposited is proportional to the charges passing through it, right? And that gives us this formula, ZIT. Let's take note. So here now, we are giving our mass to be equal to 450 grams. Here, we are going to leave it in gram. Don't usually convert when you are dealing with Faraday's law. Since this one is in gram, just leave it in gram here. Then we are giving time to be equal to 25 minutes. So, but this you have to convert to what? To second. And how do you do that? 25 multiplied by 60. So what is 25 multiplied by 60? 25 by 60 should give us 1,500 seconds. So 1,500 seconds. So, and we are given that Z is equal to 3.3 times 10 raised to power minus 4 joule per coulomb. So then the next thing is to plug in our value and apply and simplify. Exactly. So here we have our formula, which is M equal to ZIT. You're looking for I, you can decide to make I subject to the formula here before you plug in the value, or you plug in the value direct. What is our M? Our M is 450 equal to Z, electrochemical equivalent, which is 3.3 times 10 raised to power minus 4, then multiplied by I, then multiplied by time, which is 1,500. Exactly. So that I can have here 450 would be equal to, I'll multiply this by this. So if I multiply 3.3 exponential minus 4 by 1,500, I'll arrive at 0.495 multiplied by I. So divide both sides by 0.495. 0.495. This one will go with this one. I'll be left with I, which is equal to 450 divided by 0.495. And when I do that, 450 divided by 0.49, that will give us a 909.09. So I is approximately 909 amp. Are we clear? So that is about question 33. So question 33, the answer is 909. So moving on to the next question, which is question 34. The diagram above shows the time velocity time graph of a vehicle. The distance traveled in exactly half of the total time is. So we're looking for the distance traveled half of the total time. Then when you have this type of question you ask yourself is, what is the total time? Total time is equal to what? So this is your total time here. Take note, it's 90 seconds. 90 seconds. So half of the total time, half of the total time will now be equal to what? 90 divided by 2, which will be 45 seconds. So we'll now come to your diagram, and here we have, here is 50. So we assume from here should be 45. We assume from here should be 45. Right? From here should be 45. Is that understood? So just assumption, is that correct? So just an assumption. So that place should be 45. So if that is 45, here is 45. Here is 45. So we'll be looking at the distance in this velocity time graph. Distance is equal to area under the graph. Area under the graph. So we are looking at the distance from this point to this point. So we consider the area under this graph here. So if we do that, we're going to see that we consider this area, the triangle. Is that clear? We have this triangle. Then the next one is a rectangle. We have this rectangle. So we'll have this rectangle. So we're going to find the area of the triangle, add it to the area of the rectangle. That will give us the total area distance covered within the time frame of 45 seconds. I hope we are together. So now distance traveled, right? Distance traveled and half of the total time now will be equal to, let's name it A, B, C, D, E. Let's call it like that. So we're going to have triangle, area of triangle ABE plus area of rectangle BCDE. So that is area of triangle ABE plus area of rectangle, what? Rectangle BCDE. So area of triangle is half base times height plus area of rectangle is what? Length times breadth. Is that clear? So from there, area of this, that's going to be half the base of this rectangle. Here is where it stops, right? The base is from this place to this place, which is the difference between the time, when the time is 0 and when the time is 20. So it will be 20 minus 0. That will give us 20. So that is our base. Then times the height. The height is this. We are going to trace the height to the velocity axis. So the height is 80. So I have 80 plus the rectangle, the length, right? We can say here is the length, which will serve as the height as well, right? That will be 80 multiplied by the breadth, which is the width, right? This one, right? So that's going to be 45 minus 20 to give us 25. Is that clear? So that we have here to be here one, that is 10, right? I'm just saying like 20 divided by what? 2, that will be 10. So 10 times 80, that will be 800. Then plus 80 times 25. Here we have 80 times 25. That gives us 2,000. That gives us 2,000. So, and when you add them together, we have 2,800 meters. So that gives us our total distance traveled. I hope this is understood. That is option what? B. So moving on to the next question, which is question 35. Question 35 says the barometer, which function as an altimeter. Altimeter, that is the height. So is what? A mercury barometer, a fault-in barometer, an aneroid barometer, manometer. Barometer is used to measure atmospheric pressure. So the one that can serve as function as what? Altimeter, the measuring the height, right? Is a aneroid barometer. So the next question is 36, which says the concept of dispersion of white light into different colors can be explained using a reflection, refraction, diffraction, and polarization. It's a refraction using a refractive block, like a triangular block, right, which will disperse the white light into their various color, which is red, orange, yellow, green, blue, indigo, and violet. Is that clear? So it is a refraction. So then 37, we have this circuit diagram, and we are asked to find the effective capacitance of the whole circuit. Is that clear? Effective capacitance of the whole circuit. So in order to achieve this, you have to remember this concept when capacitance are in parallel and when they are in series. When capacitance are in parallel, capacitance are in parallel, the total capacitance is going to be, when capacitors are in a parallel, the total capacitance is the direct summation. When they are in series, it is a reciprocal. For instance, the formula 1 over C total equal to 1 over C1 plus 1 over C2 and so on is when it is in series. Is that clear? Okay. And the next formula CT equal to C1 plus C2 and all that is when it is in a parallel. Take note. So it's a reverse of resistors arrangement. Is that clear? So now How do you know if a circuit is in parallel or in series? A series arrangement is end-to-end arrangement, like what you have here is series. Well, when it is side-by-side arrangement, that is parallel. Like what you have between these three capacitance and this downward capacitance, they are in parallel. And another thing you know to identify parallel is if there's a junction when the current is passing. If the current is passing through this, according to this place, there's a junction. Part of the current will flow this, part of this current will flow this. Therefore, that shows you that the ones up here are in parallel to the ones down here. Is that clear? When you are done with that identification of which capacitors are in series and which are in parallel, quickly, this thing shouldn't take you time. Quickly identify, then you focus on which formula to use among these two formulas. So now I have identified, I just have to simplify this upper one first before I even consider these side ones. So in order to achieve that, I'll look at this here, they are in series, right? So I can name them C1, call this one C2, call this one C3. If I like, call this one C4, call this one C5, call this one C6, call this one C7. So I here now says C1, C2, and what? C3 are in what? Series. They are in series. Is that correct? Since they are in series, let's just use anything to represent the effective resistance. Let's say C prime. To represent what? The total capacitance, of capacitor C1, C2, and what? And C3. Is that clear? So from there, I can now say 1 over C prime will be equal to 1 over C1 plus 1 over C2 plus 1 over C3. So that I have 1 over C prime will be equal to 1 all over C1 is 3 plus 1 over C2 is 6 plus 1 over C3 is 2, right? So that I have 1 over C prime will be equal to, what is the LCM? LCM is 6. 3 in 6, that gives us what? 2, right? 2 times 1 gives us 2 here, plus 6 in 6 is 1. 1 times 1 here, that gives us 1, plus 2 in 6 is 3. 3 times 1 here gives us what? 3. So let me manage here too. So from here now, we can say our 1 over C prime will now be equal to C2 plus this, 2 plus 1 plus 3, that will give us 6 over what? Over 6. So whichever way we do, this implies that C prime is equal to what? 1 microfarad. This one multiplied by this divided by this, we're going to give you 1 microfarad. Is that understood? So the next thing, we can do the same thing to what? To C4 and C5. We can say let's say call it CR, right? Any name represent the total capacitance of C1, C4, and C5. Exactly. So let that represent it. Then we quickly now use the formula again. That is 1 over CR will be equal to 1 over C4 plus 1 over C5, since they are in a series. So that I have 1 over CR equal to 1 over C5 is 4 plus 1 over C4 is 4, C5 is also 4. So I have 1 over CR is equal to, what is the LCM? 4. That is, I'll add the remaining one, that will be what? 2. Then when I cross multiply, I have 2CR equal to what? 4. Therefore, CR will be equal to 4 all over 2, which implies we have our CR to be 2 microfarad. I hope this is understood. So the whole of this has become 1. The whole of this has become 1, which is 1, this. The whole of this has become a single, which is what? Which is this. So I can redraw my circuit like this beautifully. First one, we have something like this. Then from here, we have something like this. So we have this. We have this. It might not be perfect. Then we have this. Right? We have this. It closes here. Then from there, we have something like this. Then we have something like this. From here, we have something like this. Good. So we have something like this. So as you can see, this upper one now is now our C prime, which is one we found to be 1 microfarad. And the downward that we found, that is CR, which we found to be 2 microfarad. This side one still remains as our C7, which is also 2 microfarad. Here is our C7. And the other side here, C6, which is also 2 microfarad. So here is our C6. So as you can see now that C prime and CR, they are in parallel. So if they are in parallel, what do we do? So if they are in parallel, we said if they are in parallel, C prime and CR are arranged side by side, right? So they are in parallel, Therefore, let CT be the what? Equal to the effective or total capacitance, right? So that I will now have CT. If they are in parallel, remember the formula, we just add. So you are going to C prime plus what? CR. That will give us C prime is 1 microfarad plus CR, which is what? 2 microfarad, to give us what? 3 microfarad. So the whole of this one too has become a single capacitor of capacitance 3 microfarad. So then the next thing, we can redraw our circuit here. We can redraw our circuit now. So our circuit will now look like something like this. We now look like this. The whole of this has become 1. So we now have, let's still start from this side. Then we have something like this. It has become 1, which is now CT. It has become 1. Then it goes like this. Then we have our source of energy here. Then we have what? This particular one here. Then come back here. So here is now our CT, right? Here is our C7, and here is our C6. Our CT is now 3 microfarad. Our C7 is 2 microfarad. Our C6 is also 2 microfarad. As you can see, this current coming like this, there's no branches, they are in series. So here, C7, CT, and C6 are in series. They are in series. So since they are in series, this time around, let's say C effective BD equal to the total capacitance of the entire circuit. Is that correct? So we're going to use the formula. That's going to be 1 over C effective equal to 1 over C7 plus 1 over CT plus 1 over C6. So I have 1 over C effective will be equal to 1 over C7, which is 2, plus CT, which is 3, then plus C6, which is 6. So that from here, 1 over C effective will be equal to, the LCM here is going to be 6. 2 in 6, that is going to give us 3. 3 times 1, that will be 3. Plus 3 in 6, that will be 2. 2 times 1, that will give us 2. Plus what again? Plus 6 in 6, right? So sorry, this 6 is 2. 6 is 2, not so we still have our 6 as LCM. So 2 here is 3. 3 times 1 is 3. 3 here is 3 here is 2. 2 times this is 2. Plus 2 here is going to be what? 3. 3 times this, that will give us what? That will give us 3. 3 times 1 give us 3. So I have 1 over C effective is equal to 8. 8 all over 6. So when you cross multiply, make C effective subject to the formula, we have C effective will be equal to 6 divided by 8. So when you press your calculator, 6 divided by 8, 6 divided by 8 should give us a 0.75. So we're going to have 0.75 microfarad. Exactly. So that gives us our option to be option B. I hope the steps we follow to get our answer or arrive at the answer is understood. So that is about this question 37. The next question is question 38. Question 38 says, on which of these does the intensity of sound depend? The intensity of sound depends on amplitude, just like the pitch depends on frequency, and timbre depends on the harmonics, right? The overtone rather. So the intensity of sound depends on the amplitude. Exactly. So the next question is, the wave property which can be used to differentiate between a sound wave and light wave is polarization. Polarization is just like sound wave is a longitudinal wave and light wave is transverse wave. That's the main characteristic that differentiates a sound wave from a light wave. Exactly. So only transverse wave can be plane polarized. Are we together? So the last question is question 40. Said a meter rule of mass 15 gram pivot at the 30 centimeter mark balanced horizontally when a mass of 25 gram was hung at the 18 centimeter mark in balance horizontally. Now, if the position of the pivot is moved to the 33 centimeter mark, by how much must be the mass to be reduced to maintain the horizontal balance of the meter rule? So now here is what we have. Now this is under equilibrium. So we assume here is our meter rule, right? Starting from maybe from here is 0 down to 100. Exactly. And the question says that of mass, the meter rule has a mass of 15 grams. So remember center of mass. Center of mass is the point on which the entire mass of the body appeared to concentrate. And for meter rule, it is always at the middle. So since the meter rule is 15 grams here, so that we are going to locate our mass to be here. So let's say here is the middle. We put our mass here. We put our mass here. That is the middle. So meaning that from here to here, here is the mass, which is a 15 gram. That shows that from this point to this point is what? 50 centimeter. It's 50 centimeter. Exactly. And from here to this point also is a 50 centimeter. And they say that the meter rule is pivoted at 30 centimeter. It's supported with pivot at 30 centimeter. So if from here to here is 50, if you're counting from here being 0, moving down like this, let's assume here is what? 30. So this is where the pivot is situated. No, it's just assumption. It's not drawn to scale. So that is from here to here is what? 30 centimeter. 30. So when a mass of 25 grams is hung at 18 centimeter, so we hang a mass at 80 centimeter. If from here to here is 30, so let's say here is 20, here is 20, maybe here should be 18, just assumption. Let's say here is what? 18. So if that place is 18, that is why we hang a mass of what? A mass of a mass of 25 grams. That's where we hang it. So we hang a mass of 25 gram here. Exactly. And that is at a distance of 18 centimeter. So now you have to balance the distance now. If from here to this point is 50, and from here to this point is 30, what will be from here to here? Right? That is what will be from this place to this place. That should be what? 50 minus 30, that will give us 20. Also, if from here to this point, you can see where I'm using my marker. From here to here is what? Is 30. What will be from here to here? From here to here is 30, and from here to here is what? 18. What will be this middle? That will be what? 30 minus what? 18. That will give us what? 30 minus 18 will give us 12. Exactly. So remember they told us that it balanced horizontally. So we are going to confirm it now. Here is what? Clockwise. Here is what? Anti-clockwise movement. So condition for the parallel coplanar forces is that the clockwise moment must be equal to what? Anti-clockwise moment. Is that correct? So we have 15 multiplied by the perpendicular distance in respect to the pivot, taking moment about the pivot, that will be 20. So it should be equal to what? The anti-clockwise, 25 multiplied by what? 12. So that will be 15 multiplied by 20 is 300. Is 300. So here also is 300. So according to what they say, it balances horizontally. Now, this is where the main question is. If this rule is now in its position such that it balances at what? At the 30 centimeter mark. So here is the meter rule now. Here is the meter rule. And the main position, our mass is still at the middle. Our mass is still at the middle here, right? The mass is still at the middle, which implies that from here to here is still what? Is still 50 centimeter. And from here to here is 50 centimeter, right? So our mass is 25 gram. Then the new position rather is that the pivot is now at the 33 centimeter. So the pivot is now at 33 centimeter. The pivot is now at 33 centimeter. Let's say here is 33. You know, I told this assumption. So here is 33. The pivot is now at 33 centimeter. That is from here to this point is 33 centimeter. So 33 centimeter. So the next thing is that said, how much must be the mass to be reduced to maintain the what? To maintain the balancing, the horizontal balance of what? Of the meter rule. Is that clear? So we still position that mass. We don't know the mass, but we position it at that distance, which is 18 centimeter, right? So we position the mass at that distance, which is 18 centimeter. We don't know that mass. Let the mass be what? Let the mass be M. So we position it still at the same distance, but the only thing that changes is the position of the pivot, right? If you do the practical, you understand what we are talking about here. It's still at the 18 centimeter. So the new thing now here is that here's our mass M that we don't know, right? So what will be the distance from here to this point, right? If from here to here is 33, so and from here to here is 18, what will be from here to here? That will be 33 minus 18. That will give us 15, right? That will give us 15. Here's 15 centimeter, right? Now, if from here to here is 50 and from here to here is 33, then what will be from here to here? That will be 50 minus what? 33 to give us what? 17. Is that clear? Is there anything we are missing? Oh, sorry, it's not 25, it's 15. Oh, sorry, yes. So to give us what? 15. So from here to here is 15. Our mass at the center Is 50. It's from here to here is 17 rather. Thank you. So it's 17. So the same thing, we're going to apply clockwise moment is equal to what? Anti-clockwise moment. So clockwise moment is 15 multiplied by what? 17. The perpendicular distance is equal to the mass multiplied by what? 15. Exactly. So that mass will be equal to 15 multiplied by 17 all over what? 15. That will give us what? That will give us 17. 15 cancel 15. We have what? 17 graph. Is that understood? So this is how to apply this question, this approach, this question. I hope it is understood. So our correct answer here is option what? Option C. Option, no, the mass to be reduced. Now, since this is the 15, 17, right? The reduction will now be what? Reduction in mass. Reduction in mass will now be equal to what? The initial mass, 25 gram, minus what we have now, which is a 17 gram. That will give us what? That will give us our final answer to be 25 minus what? 17, that will give us 8. That will give us 8 gram. So that is the reduction. So we have to reduce the mass by 8 gram in order for us to balance it horizontally. So the correct answer is 8. Please, you see this kind of question, you can fail it if you just focus on what you have without looking at what the answer question actually demands. So that is about question 40. And call it a wrap up for 2021 past question solution series. I hope you enjoyed the class. Should you have any further questions, please let me know in the comment section. I will take it from there. Thank you for your time. God bless you.